Okay, we're going to continue reviewing. Today we're going to look at finding the solution set of an equation, y equals 8 minus 3x, if we're given a replacement set. So we're only trying these values. We're not finding all solutions. We're just finding the ones of these. So all that means you do is you're going to take your equation, and everywhere there's an x you're going to put a 4, and everywhere there's a y you're going to put a negative 4. Remember, it's true. It is a solution if it makes it true. So we'd have negative 4 equals 8 minus 3 times 4. 3 times 4 is 12, 8 minus 12 is negative 4, so that one is a solution. So where I'm going to write my answer, it needs to contain the ordered pair 4, negative 4. So now I'm going to try 8, 0. So, okay, 0 equals 8 minus 3 times 8. Well, that's 24, 8 minus 24 is 0, so that one's not going to work. So now I'm going to try 2, 2. So I put a 2 in, equals 8 minus 3 times 2. 3 times 2 is 6, 8 minus 2 is 2, so 2, 2 does work, so I want to include it in my solution. Now I need to try the ordered pair 3, 3. So 3 equal 8 minus 3 times 3. 3 times 3 is 9, that would give me negative 1, so no. So these two ordered pairs would be the solutions from what I was given to start with. And make sure you write it as a set of ordered pairs. Is this a linear equation is the first question, and then if so, write it in standard form. So what is standard form? AX plus BY equals C, and remember we had some restrictions. A has to be greater than 0, A and B both can't be 0, no fractions, and the GCF has to be 1. So once we think we get it in there, we got to go through and make sure all those things are right. To be a linear equation, it needs an X and a Y. One of them can be missing, but not both. Okay? And they need to be either added or subtracted. It can't have powers of variables and things like that. So number 2 here looks like it could be linear. It doesn't fit standard form yet for a couple of reasons. One, the y is over here, and also it's got fractions. So let's get rid of those fractions first, just to take care of that. So to get rid of a fraction, remember you find the common denominator and you're going to multiply by that. Well, here the common denominator is 5, so I have to multiply each term by 5. Here the 5's cancel, leaving me 3x. Here it's really 5 over 1, so nothing cancels. Minus 25. 5's cancel, leaving me 2y. So now I need to get the y on the left side because the y is on the left. So I'm going to minus 2y from each side. There's really nothing I can minus it from over here, so it's just, I'm going to put it second because I know I do want it second here in a minute. And 2y minus 2y is 0. Does that look like standard form? Well, I got my x and y on the left, but where does that number need to be on the right? So I'm going to go back and add 25 to each side. And I get 3x minus 2y equal 25. So that looks pretty good. Let's go through. Is a positive? Yes, it is. X and y, or a and b, both aren't 0 because we have the terms there. No fractions. Does anything go into 3, 2, and 25? So no. So this is a yes. It's a linear function. Don't forget to put that somewhere, a linear equation, and then the final answer. Is this a linear equation? Well, again, if you're not sure, start trying to get it in standard form. Well, to get rid of our fraction, we'd have to multiply everything by y. And when we do that, we're going to get here x times y at the beginning, so that tells us no. So you can never have a variable in the denominator. You can have numbers because you can multiply them out, but you can never get rid of a variable in the denominator without getting two variables being multiplied. So that would be a no, and we couldn't put it in standard form then. All right, next we're asked to graph. Well, if you remember, x equals 3 is a special graph. If you don't remember, you can go ahead and make an xy table. But when you choose values, you really don't have any choice for x. X is always 3, 3, 3. Doesn't really matter what the y is, 0, 1, 2, or whatever. So 3, 0, 3, 1, 3, 2. So what kind of line is it? It is a vertical line. So that would be problem 4. Now in number 5, it is in the form y equals, which is what we want to make sure of first. So we do get to choose some values. Again, choose 0. Choose wisely so you don't get fractions, but this is a pretty easy one. 5 minus 0 is 5. If I choose 1, 5 minus 1 is 4. If I choose 2, 5 minus 2 is 3. So 0, right or left, and up 5. 1, 4, right 1, and up 4. And then 2, 3, right 2, up 3. And again, if they don't turn out to be a straight line, that's a clue to you that you've done something wrong. So that would be number 5 in graphing those. So remember, if it just has an x or a y equal a number, it'll be a special situation. If you know what it is, you can just graph it. If you need to make a table, follow the directions there. Needs to be in the form y equals to graph it though. This one is not in the form y equals, so we need to do some work to it. So we got to get the y by itself, so we're going to, oops, sorry about that, got to go backwards. So we need to subtract x from each side. So if I subtract x from each side, I'm running out of room here, I guess I'll write it up here. We get negative y equals 3 minus x. I don't want negative y, so I'm going to divide everything by negative 1. Remember, we practiced that yesterday. And we get negative 3 plus x. Another way to think of that would be x minus 3. That's what I'm going to use when I make my table. So if I put a 0 in, I'm going to get negative 3. If I put a 1 in, negative 3 plus 1 would be negative 2. What am I going to get if I put a 0 or a 3 in? Negative 3 plus 3 would be 0. So negative 0, negative 3 don't go anywhere right or left and go down 3. 1, negative 2. And 3, 0, go right 3, and there it is. Again, draw your line through it, and you are done.